string form. Actually, there are the two forms. It is a simple form and a string form. Here I am taking that is a Q1, Q2, so on Qm are the string forms. Now, let Q1, Q2, so on Qn be the positive integers. If Q1 plus Q2 plus so on Qn minus n plus 1 objects are put into the n boxes, then either the first box contains at least Q1 objects, or the second box contains at least Q2 objects, so on. Nth box contains that is a Qn objects. It means that all the objects I should be adjust into the available elements. That is called as a pigeonhole principle for the string form. So what should I do here? Proof point of view. Actually, contradiction I will take the first. It is not the true if I take ith box contains at most Qi minus 1 objects for I equal to 1 to n. It means that is a Q1 minus 1, Q1 minus 2, Q1 minus 3. Then the number of objects contained in the n box at most Q1 plus Q1 minus 1 plus Q2 minus 1 plus so on Qn minus 1 equal to what are that? It's a Q1 plus Q2 plus so on Qn minus n, which is 1 less than the number of objects distributed. This is a contradiction. Hence, the statement of the principle must be true. The simple form of the principle pigeonhole principle is obtained from the strings by the Q1, Q2. Your statement is a false, so that it is correctly, it is a distributed. Therefore, it is a fitted, that is a distribution. Therefore, principle must be true. That proof is over. Now, generalization point of view, if I take n pigeons are accommodated into the m pigeons, n is greater than m. Then one of the pigeonholes must be contain at least n minus 1 by m plus 1 pigeons, where bracket x is denote the greatest integer less than or equal to the x. So that bracket of n minus 1 by m plus 1. Proof point of it is a 17.5.3 also important. Proof point of it is a contradiction. Suppose the each pigeonhole contains at the most n minus 1 by m pigeons I am taking. Then the maximum number of the pigeons in all the m pigeonholes is m into n minus 1 by m. It is less than or equal to n into m minus 1 by n. M cancels, so that n minus m. This is contradictory, assumes that is there are n pigeons only. So hence it is the result is true. Here, example, it is if we take that is a kn minus plus 1, it is a also it is a n is will be divided, so that it is a k plus 1 pigeons is exist. This is a 5 marks question, is important. 4 marks. There is a number, 3 numbers are chosen at random. Their sum is 19. Show that at least one number is 7 or more.
This is, sir, which question?
Hello? What tell me?
Sir.
Chappan.
Sir, which question, sir? Are the important?
17.5.5. Amma screen kanpistale?
అది మీ మాటలు బ్రేక్ అవుతున్నాయి సార్ మధ్యలో అందుకని.
అవునా? 1 second. ధృతి ఒకసారి లోపల ఫ్యాన్ ఆఫ్ చేయ. ఫ్యాన్ ఆఫ్ చేయ. వాయిస్ అమ్మ వాయిస్ వినపడుతుంది ఇప్పుడు?
బాగుంది సార్.
ఓకే రైట్. అమ్మ మీరు అడుగుతున్న క్వశ్చన్ ఏంటో అడిగారు.
అది ఇంపార్టెంట్ 5 మార్క్స్ అన్నారు కదా సార్, విచ్ క్వశ్చన్? 17.5.
Okay. So example, their numbers, three numbers are chosen at random. Their sum is 19. Show that at least one number is a 7 or more. We identify the 3 numbers are the pigeonholes. We just identify the sum 19 as a number of the 19 pigeons.
kn plus
And
1
take
plus
that is
1.
n equal to 3. వాళ్ళ ఇచ్చారు కాబట్టి kn plus 1 equal to 19. It is a k equal to 6. At the time only 6 3 is 18. 18 plus 1. So that k equal to 6. Therefore, the
Okay.
at least pigeonhole that can be contained at least 6 plus 1. And k plus 1. As per the above formula. Therefore, 6 plus 1 equal to 7 pigeons. That's all. There are the one number that is greater than or equal to 7. So 6 kante ekku ekku undali. That's all. This is 7 marks question. 5 marks question. In a group of 8 students, this is mere chuskondi kindi ichchadu answer proof undi. Idi important amma. 17.5.7. The numbers 1 to 10 are arranged into the random order around the circle C. Show that there are the 3 consecutive numbers whose sum is at least 17. Then the numbers in order, they appear around the circle, be labeled by the A1, A2, so on, A10. Then the trade of the consecutive numbers are the A1, A2, so on, A3, A2, A3, A4, A3, A4, A5, so on, like that. It is a A9, A10. Again, it comes to the A1. And A10, A1, A2. There are the 10 in numbers. There the sum is how much it is A1 plus A2 plus A3, A2 plus A3 plus A4, so on A10 plus A1 plus A2. Like each of the numbers from the 1 to 10 occurs exactly thrice. So that it is a 3 times of A1 plus A2 plus so on plus A10. Therefore, it is a 3 times of how many we can get 1 to 10 numbers, no? So that 3 times of 1 plus 2 plus 3 plus so on 10. So its sum is equal to 165. You have 10 triples. Therefore, some of these triples is a 165. So places of the 165 pigeons in the 10 pigeon holes. 10 pigeon holes. Since it is a 165 greater than 10 into 16. By this pigeon holes principles, we have contained at least pigeon holes are the 16 plus 1 equal to 17. 16 plus 1 equal to 17. Because of it is there we have that is the numbers are the arranged 1 to 10. Actually, I got it. The number is a 3 into 1 plus 2 plus 3 plus so on 10. So that 165. That 165, I want to divide into the 10, 1 to 10 arrangements, no? 10 numbers, 10 pigeons. If I divide, I can get that is a 16 only. So 165 greater than 10 into 16. So k equal to how much? 16. So pigeons are the 16 plus 1 is the best way. So that it is a at least means greater than 16 plus 1 equal to 17 pigeons. That's all. This is important. Next, similarly, you can do this one. Next, generating function. I explained in the last session, generating functions and many concepts before the last class I explained. The same concepts, it is a basic concept, basic things we will revise once again. Ordinary generating function for the infinite sequence A0, A1, so on is the formal powers of the x means it is a sum of all the numbers. We can write A0 plus A1x plus A2 x squared plus so on. That series is we can write summation n equal to 0 to infinity a n into x power n. Here between of the sequence and its generating functions, which is with the double sides arrow as for the example A0, A1, so A2, so on. That we can write as A0 plus A1x plus A2 x squared plus so on. So 0, 0, 0, that implies 0 plus 0 into x plus 0 into x squared plus so on equal to 0. 1, 0, 0, 0 means 1 plus 0 into x plus 0 into x squared plus so on equal to 1. 3, 2, 1, 1. That these are the examples for the how we can represent it to the generating function. Generating function means it is we can write as A0 plus A1x plus A2 x squared plus so on. That's all. That is if infinite sequences. Here, some of the expressions we can write as a 1 plus x squared plus so on equal to 1 by 1 minus x. Similarly, if we write that is a 1 minus x plus x squared minus x cube plus so on equal to 1 by 1 minus, above 1 is a 1 minus x, bottom is a 1 plus x. Similarly, 1 plus ax plus a square x square plus so on, x square plus so on. At the time, I can write that is a 1 by 1 minus ax. 1 plus x square plus x to the power of 4. That we can write 1 by 1 minus x square. These all are the generating functions. Here, this is one more generating functions. 2 is any constant. That is multiple of the constant. So generators are the 2, 0, 2, 0 like that. Above generators are the 1, 0, 1, 0. We can represent 1 by 1 minus x square. So that like we can write it. Next, scaling rule means it is a constant. We can be multiplied for that any arbitrary function. That is a representation of a generating function. We can write as a C A0 into C A1 equal to so on. C A0 plus C A1 x plus C A2 x square plus so on. C if I take constant is a common, C into x we can write. That is called as a scaling rule. Examples are the 1, 1, 1 will be there. 1 by 1 minus x is here. 1 minus 1 minus 1 minus 1. Continuously it will repeat, it will come. So that it will come into the 1 by 1 plus x. Next, addition rule, if I apply that, here any two functions, so I can add it, that is a of x plus b of x. Next, right shifting. Addition rule means it is separating the terms a of x plus b of x. Next, right shifting also I can be apply. Shifting means it is a one is a movement I can take the left. So all zeros will be there. So that it is a power k into a power, x to the power of k into a of x I can write. 0 plus 0 into x plus 1 plus 0 into x power k minus 1 plus a naught x power k plus a1 into x power k plus 1 plus so on. X power k into a naught plus a1 x plus so on. So x power k into a of x. Next, derivative rule, it will come to the d by dx of the term means it is the next term it will happen. So that a by dx of a of x equal to a dash of x I can take. So derivation of the functions d by dx of 1 plus x square is also d by dx of 1 by 1 minus x equal to minus 1 by 1 minus x square. Similarly, 1, 2, 3, so on will be there. Then I can write that is a 1 by 1 minus x whole square is the function that is after the derivation. We can get that is a useful results finding of generative functions and sequences. Examples of generating of the sequence of the squares, he will ask in the exam. What should we do here? 0, 1, 4, 9, so that it is a considering that is a one multiples here 0 into 0, 1 into 1, 2 into 2, like that I can take 3 into 3. The finding of the generating functions of the sequences, all once if I take, it is a 1 by 1 minus x. 1, 2, 3, 4, if I take 1 by 1 minus x square. Then 0, 1, 2, 3, 4, if I take x by 1 minus x whole square. 1, 4, 9, 16, if I take d by dx of x by 1 minus x whole square. 0, 1, 4, 9, 16, if I take x into 1 plus x by 1 minus x whole cube. The generating function for the sequence 0, 1, 2, 4, 9, 16, I can write as x into 1 plus x by 1 minus x whole cube. Next, Fibonacci series. Fibonacci series means if I will add that is the 0, if added to the 1, next number, I will get that is a third number. Next, second and third, if I added, fourth number. Third and fourth, if I added, fifth number. Fourth and fifth, if I added, I will get the sixth number. Sixth and fourth, if I added, I will get the seventh number. So like that, it is a sequence is called as a Fibonacci sequence or generating function of the Fibonacci sequence we called. So here, solution point of view, it is also important. I can take that as f naught equal to 0, f1 equal to 1, f2 equal to f1 plus f naught. Here, generating function f of x equal to f naught plus f1x plus f2 x square plus f3x, so on. So 0, 1, if I add it to the 1 plus f naught plus f2 plus f1, f3 plus f1. Next, these are the functions sequence. If I take f naught f1, it is a capital F of x, and 0, 1 means it is a x, and the product of x into f of x and x square into f of x. So that this rule automatically it will be added. I can get that is x plus capital F x into f of x plus x square into f of x. So that I can get that the function is a x divided by 1 minus x square. This is called as generative function of the Fibonacci series. It's most important. It is a 17.6.4. Product rule, if I apply that, it is a of x into a of x, then I can take that as a, this is a sequence form is a summation n equal to 0 into c n x to the power of n. Method of calculating the coefficients of x is a generating function. Generating function, I can take 1 minus x whole to the power of n plus 1 by 1 minus x equal to, I can write as a 1 plus x square plus 1 x to the power of m. 1 by 1 minus x equal to 1 plus x square plus 1. 1 plus x whole to the power of n equal to 1 plus c. Now here, product rule, we can take the c of x. Now here, find the coefficient of x to the power of 16, he will ask. So n1 equal to how many elements we have? Here 5 ₹2 coins. Here question is, he will ask like this: how many ways that there to pay the amount of 21 rupees if the have that is a 6 is ₹1 coins, 5 ₹2 coins, and 4 ₹5 coins. So that it is a, I can take that is a coins at the 0, 1, 2, 3, so on up to 5, 6, and another is a 0, 2, 4, 6, 8, and 10, another 0, 5, 15. How many we have? N1 plus N2 plus N3 equal to 21. So coins of the ₹1, ₹2, and ₹5 will be, I will distribute into the 1 plus x square plus so on x to the power of 6 into 1 plus x square plus x to the power of 4, x to the power of 6, so on x to the power of 10 into 1 plus x to the power of 5 plus x to the power of 10 plus x to the power of 15 plus x to the power of 20. All together, I can get that is a one of the power x to the power of 21 is a product. Hence, that is a equivalent to the 9 only. This is a one of the information we can get it here. Next, convolution rule. Convolution rule, we can take that it is a, he will ask that is a find the coefficients of x, y, z square in the 2x minus y minus z whole to the power of 4. So 2x minus y minus z whole to the power of 4 equal to 2x minus y minus z into 2x minus y minus z, and like that up to 4 times. Here it is clearly coefficient. If I observe highest, it is x, y, z square. I can get in the middle of the term. So that it is a total how many degree? It is a total. I can take the 4 factorial by here x, y, z, and the z's are the how many? 2 are there. So that 1 factorial into 1 factorial into 2 factorial, that is equal to the 12 choices. The coefficient of the single term x, y, z square is a 2 into minus 1 into minus 1 whole square equal to minus 2. So since it is a 12 such terms is the entire product. Therefore, I can get that is a total how many product we have? Here we have that is a 2x, y, z square is a coefficient, and it is a product of 2x minus y, z square is clearly I can take that is a 12 elements into it is minus 2. So that is minus 24. That is a coefficient. It's most important. Next summary. Here we discussed that is a what we discussed the concepts, all will be implemented. Okay. So this is the overall idea. Rest of that, another 7 minutes will be there. Do you have any doubts in this unit 17? If you have any doubt, you can ask now. Okay, fine, Namma. Now, old question papers already clearly I instructed into the classroom teaching, conventional teaching. In that particular, I clearly mentioned you should refer that is a old question papers, 2 to 3 question papers thoroughly you should be prepared. Okay, in that already I clearly mentioned all of the important questions will be there. The questions and simultaneously topic wise what I mentioned the important questions, so that all if you will prepare, you can get that is a full marks. More than 60, 70% and 80% also. Last time some students got that is a 86% also. So that 86, 90% based on the internal marks. So that assignment submission. Here also you can
when is the exams going to start, sir? Date?
Mostly in soon. It means that after 15 days, 15 or 1 month. Any more?
Thank you, sir.
Okay, start preparation, Amma. Already old question papers thoroughly prepare it. It's the most important. And in the regular classes, I mention important questions. While I am teaching, it is important, this is important, this is important. That is also should be prepared.
Sir, alternative days will be there in the exams or else regular, sir?
Amma, hall ticket they will give you. In that, they will tell that is a particular days also. Your middle of that holiday will be there or continuously. Okay, that we cannot expect well in advance.
Okay, sir. Thank you.
Okay.
Sir.
Tell me.
Sir, next week last class antunar kada. Appudu okasari malli okasari important questions exam point of view lo cheptara sir.
Next week ee week last class నాకు తెలిసి ఈ వీక్ అనుకుంటాను.
లేదు సార్, అది విజయ్ సార్ సాటర్డే లాస్ట్ క్లాస్ అంటున్నారు సార్.
Okay, if case last class will be there, we can discuss.
ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూ లో మళ్ళీ ఒకసారి ఇంపార్టెంట్ క్వశ్చన్స్ చెప్తే వాటి వరకు మళ్ళీ ప్రిపేర్ అవుతాం సార్.
నీకు ఆల్రెడీ పర్టికులర్ గా చెప్తున్నాను, ఓల్డ్ క్వశ్చన్ పేపర్స్ లాస్ట్ 3 years ముద్ద ఉంచుకొని ఫస్ట్ ప్రిపేర్ అయిపో.
Sir, ID card is compulsory, sir, to sit in the examination hall.
అమ్మా
ID card is compulsory, sir, for sitting in
Yes,
the
yes.
examination hall, or
Yes, yes.
no need, sir?
Yes, ID card is important.
Okay, thank you, sir.
Hall ticket and ID cards are important.
Okay, thank you, sir.
సాటర్డే నెక్స్ట్ సాటర్డే లాస్ట్ క్లాస్ అని చెప్పి విజయ్ సార్ చెప్పారు సార్ ఇందాక.
Okay, if it will be there, I will revise some. Even though it is
Okay,
not
sir.
there also, you should be thoroughly last 3 years question papers, thoroughly you prepare. And what are the important questions we discussed? Once again, you total revision also you should do it. Total
Okay,
concepts
sir.
once you thoroughly once revise it. Okay?
Okay, sir. Okay, sir.
Because of you can write in your own way. Such a way also you should be prepared.
Okay, sir.
Mostly you can expect that is the last 3 years question paper. If you will thoroughly prepare, then you can write well in exam.
సబ్జెక్ట్స్ అన్ని కూడా అంతేనా సార్?
Usually PG will be being like that only. Because of syllabus less and all will be the same. And it is a values maybe changes, but is a question will be come into that particular area only.
Okay, okay, sir.
Values may be the change. Mathematics means values may be the change. Problems will be there, values will be changed. Next year, people are statements and almost all the theorems only will be there. That all are the highly important questions. So that usually that will be repeated. In a master degree, totally theory, no. So that mostly it will be the repeatedly it will become. Okay, now.
Okay, sir.
Okay. Any more? Anyone? Yeah, old question papers you can collect from the Vijay sir also. Sir, he can provide you. Anything assignments already I think submitted.
Yes, sir.
That part corrections will take up into the Zoom. So that marks we can be posted. But the thing is, preparation is the most important for the end examination. You will prepare well. That all I can suggest to you.
Okay, sir.
Okay.
Okay, sir.
What I mentioned in the classroom, it is important questions. That one second.
Sir, questions will come from assignments also, sir.
Assignments also. Old question papers, thoroughly 3 question papers you prepare, and already that repeated questions are already available in the assignment. So
okay, sir.
అంటే అసైన్మెంట్స్ లో క్వశ్చన్స్ కూడా ప్రిపేర్ అవ్వమంటారా అయితే?
అవునవును, ప్రిపేర్ అవ్వాలమ్మా.
ఓకే సార్.
ఓకేనా? Particularly some of the units వదిలేయద్దు. ఒకటి గ్రాఫ్ థియరీ from the starting unit 1 to 2 3 4 1 to 6 వరకు వదలకుండా చూసుకోవాలి. నెక్స్ట్ గ్రాఫ్ థియరీ కంపల్సరీ వదలకుండా చూసుకోవాలి. జనరేటింగ్ ఫంక్షన్స్ వదలకుండా చూసుకోవాలి. దెన్ కౌంటింగ్ ఆఫ్ ద ఇప్పుడు లాస్ట్ 17 యూనిట్లు థియరీ 16 అండ్ ప్రీవియస్ క్లాసెస్ లో చెప్పిన 14 15 16 ఆల్సో థియరీ కూడా మొత్తం చూసుకుంటే సరిపోతుంది. ఆల్మోస్ట్ కెన్ గెట్ 70%.
సార్ ఇంకోసారి చెప్పండి. గ్రాఫ్ థియరీ 1 to 6 చాప్టర్స్ లో కూడా చూసుకోమంటారు అయితే?
6 అండ్ గ్రాఫ్ థియరీ,
ఇంకా జనరేటింగ్ ఫంక్షన్స్, ఇంకా
జనరేటింగ్ ఫంక్షన్స్, తర్వాత కౌంటింగ్ ప్రిన్సిపల్స్ అండ్ అది 17 నా ఇప్పుడు డిస్కస్ చేసిన టాపిక్. నెక్స్ట్ వచ్చేసి అంతకుముందు డిస్కస్ చేసిన గ్రామర్స్ పార్ట్ లో కూడా డిస్కస్ చేసిన టాపిక్స్ థియరీ ఉంటుంది కాబట్టి అందులో స్టాండర్డ్ ఇంపార్టెంట్ క్వశ్చన్స్ ప్రిపేర్ అవ్వండి. ఓకేనా?
ఓకే సార్.
ఓకే అమ్మా. ఓకే, టైమ్ అప్. ఓకే, all the best amma. If we have any additional classes, we can discuss the question papers.
Okay, sir.
Okay,
sir. Okay, sir.
Okay,
thank you.
Thank you, sir. Thank you, sir.
Okay, all the best. Right.
Thank you, sir.